All right, this video we're going to go over numbers 4 through 6 on our Diff Eq review. And these three questions are all exactly the same. We're given a differential equation and we're asked to find the original equation, find the solution here. And we only know one way to do that in AP Calculus AB, that's separation of variables. So the only option here is to go ahead and separate and then integrate both sides. So once we see this question format, we got to have that in our head, that the only way we know how to do this is to separate. So for number 4 here, multiply the y cubed across, keep the dy, then multiply the dx across, keep the 7x squared. Then take the antiderivative of both sides. Nice, just anti-differentiation power rule here. So this is going to be 1/4 y to the 4th equals 7/3 x cubed plus c. Remember, we only need a plus c on one side, even though we've taken two antiderivatives here. Because if you had a plus c on both sides, you would just move them over so they're on the same side and combine them. And an unknown constant plus an unknown constant is an unknown constant, so you don't need two separate ones. At this point, you have two different choices. You can go ahead and solve for y now with this left as a c, or, and then once y is solved for and you kept it as a c, then your last step, plug in the initial condition and then find c. Or you can find c first and then solve for y using that c. Now, when you do this, it's possible that you're going to get two different c values, but in the end, the equation should simplify to be the same thing. I almost always recommend plugging in the initial condition now to figure out the actual value for c and then solve for y, because it's just less letters to deal with, and for most of us that makes life a lot easier. So I'm going to go ahead and do that. I'm going to plug in 2 for y, and if I plug in 2 for y, it's going to be 2 to the 4th, which is 16, divided by 4, which is 4. And then plug in 3 for x, so that's 3 cubed, but then I'm dividing it by 3, so that's just 3 squared, which is 9, times 7, which is 63, plus c. So negative 59 is going to equal c. Now, we're not done because we have to find the equation for y in terms of x. So now we have to go back and say, okay, well, 1/4 y to the 4th equals 7/3 x cubed minus 59. And now we're going to solve for y. So now I have to multiply the 4 over. So y to the 4th is going to equal 28/3 x cubed minus 59 times 4, which is 236. Now we take the 4th root, so y equals plus or minus, because it's a 4th root, 28 over 3 x cubed minus 236. Now, you have to actually decide which one to pick, the plus or the minus. And the way that we decide is we see, well, depending on which one I pick, plus or minus, I may or may not go through this actual initial condition. So what we need to do is we need to say, okay, if I plugged in 3 for x, which one, the positive version or the negative version, would give me an output of positive 2? Well, the positive version, because no matter what I put in here, I'm going to get a positive out unless I have that negative in front. So it's the positive version that we're going to choose, not the negative version here. But it's important to think about that. Sometimes I always pick the highlighter instead of the eraser. Sometimes I will have to choose the negative version, and so it's important that we consider which one we actually need to choose. It's the positive version this time. All right, number 5 same problem type, same issue. We only know one way to solve this, so we're going to separate. So 1 over y dy is equal to 5x squared dx. Anti-differentiate both sides. Be careful with the antiderivative of 1 over y. It is the natural log of the absolute value of y. Just like the plus and minus in the previous problem, sometimes that absolute value will be very, very important. Then this is going to be 5/3 x cubed plus c. I recommend plugging in now to find your c value. This is going to be natural log of 6. Now what happened to my absolute value? Well, the absolute value of 6 is 6, so I just didn't have to write it. Equals c, because we plugged in 0 for x. So then we come back and we say, all right, I know what c is. Now let me go ahead and solve for y. So the natural log of the absolute value of y is equal to 5/3 x cubed plus the natural log of 6. Got to get rid of our natural log, so we need e. So we're going to have the absolute value of y equals e to this whole deal. Now when you take e and make it the base of this whole thing, so that's how we're sort of canceling out the natural log there, I now have addition inside my exponent, so that can then be turned into multiplication of the two powers. So we're going to really have then e to the 5/3 x cubed times e to the ln of 6. And that's nice because, well, I don't have to do that, but it does make it look a little cleaner because now this e to the ln of 6 is just 6. So now absolute value of y is equal to e. Let's get rid of that e there. Let's make it a 6 up front. And then e to the 5/3 x cubed. Now, just like before with the fourth root, with this absolute value, really, to solve for y, I need to get rid of that absolute value, which means that y equals plus and minus 6e to the 5/3 x cubed. And so again, we think about the initial condition. If I plug 0 in for x, do I have to have the plus or the minus version to get positive 6 out? And again, it's the positive version that I need. So I can get rid of this plus or minus. And so that's twice that if you forgot to think about the plus and minus, you would actually get the problem correct, but that's not always going to be the case. All right, number 6, same question type, given some differential equation and an initial condition, find the solution, find y. The only way we know how to do that is to separate. This one's a little trickier to separate if you think about it. One way to think about it is you're going to factor out a y and then move that to the other side. We can also just think about multiplying both sides by y, and that would actually then cancel out both of these y's in the bottom. But either way you think about it, you're going to get y dy is equal to 1 over 1 plus x squared dx. Integrate both sides. When we do that, the antiderivative here is 1/2 y squared. And here, got to remember your rules, stuff you must know, this becomes inverse tangent of x plus c. Plug in our initial condition, plug in 2 for y, square it, cut it in half, you get 2 back out. Inverse tangent of 0 is 0, so we get c as 2. This was from the previous problem. So then we get 1/2 y squared is equal to inverse tangent of x plus 2. Multiply everything by 2, take the square root, we get y equals plus and minus the square root of 2 inverse tangent of x plus 4. And again, we need to consider the plus and minus, but from my initial condition, if I plug in 0 and want to get a positive 2 out, that only happens if I choose the positive version. So in all three of these, it was the positive version that you wanted in the end, but it is something that we really do need to consider. Okay, so that's 4 through 6. One more video for the last one.